Now, the questions we're talking about here are about loan repayments. Now, we try and set up a pattern again, like we did before with the annuities type questions, but it's obviously different because we're making a repayment of a certain amount, and generally the questions are going to be about what's the repayment going to be, and we've got to calculate that, and always will depend on what parameters we have, how much we borrow, how long it's being paid off for, how many repayments, what the rate of the interest is. So we've got to take that all into a consideration. So let's have a look at basically what the idea of making a repayment is and what happens. So in this case, you've got Farmer Brown buying a $250,000 harvester. So he wants to pay it over in 3 years at 14.5% per annum. So, and the instalments are being made yearly. So what's going to happen? The 250,000 is going to sit there. He takes out the loan, and they're just going to charge him interest for the year, and it's not a nice interest rate. 14.5% is pretty high. So they're going to charge you interest on that amount. So that's why it's multiplied by the 1.145. So the interest is charged on the amount in that first year. At the end of the first year, though, he's going to make a payment. Now we're going to call that payment M. You could use any pronoun you like. M is generally used, but you could use P, you could use R, you could use anything, any letter you like. So M standing for a repayment that's made. So interest is there. So obviously this amount would be more than 250,000 because it's going to increase, because it's the principal plus the interest. But then you're going to make a repayment, so it'll drop below that 250 mark. If you're not making a repayment that's more than what the interest is, then it's just going to keep increasing. So it's obviously going to be more than the interest. So what happens in the second year? We have this amount that's left. So 250,000 times the interest rate minus that repayment, and all that's outstanding. And that's the idea of compound or reducible interest in this case, is that it's only interest is only charged on what's outstanding. So that's going to be charged on the outstanding amount, which is this. So we multiply the outstanding amount by the interest rate, and then he's going to make another repayment. So the M gets taken off again. So on the same instalment, you're making equal yearly instalments. So M's going to be the same every time. So making this look a little bit more simple, we multiply the 250 by 1.145 by the 1.145, which that makes it squared, and this minus M gets multiplied by the 1.145, and there's our minus M at the end. So at the third year, you can start to see the pattern. So this amount that was left at the end of the second year has interest charged on it, so the 1.145 multiplies by the interest again, so that's why it's cubed in this case. It becomes a squared. It gets multiplied just by the minus 1.145, and then we make another repayment, so minus M again. So that's the 3 years. So only paying it off over 3 years. So that brings us the idea that the amount that's outstanding at the end of 3 years in this case, if we paid the loan off, would be zero. So as our statement stands here, we've got two unknowns, A3 and M, and we wanted to find M. So we've got to get it to this point where A3 is going to be equal to 0, and that's going to be the case, the outstanding amount. A1 is the outstanding amount after 1 year, A2 is the outstanding amount after 2 years, and A3 is the outstanding amount after 3 years. And if you've paid off the loan, the outstanding amount must be 0. So that's why we're able to make this statement and put it all equal to 0. So what we're left with now is, let's get M as our by itself, so because it's our unknown. So we add these parts on both sides, so that's why they become positive on the right hand side of the equation. It's starting to get the M's away from everything else, so we factorize M out, and we see we've got this series happening. All we've done in this line is just rearrange that series. So, but if we notice, we've got a geometric progression: 1.145, 1.145 squared. So A is 1, R is 1.145, and obviously we've got 3 terms because we can count them up. If you really wanted to, you could do that together if you like. There's not that many terms. For the sake of these types of questions, I'm going to apply the sum of a geometric series there. So the 1 That's either 1 times 1.145 to the power of 3 minus 1 over the 1.145 minus 1. So you got A, R, and N being put in the equation. And then, because it's multiplying by M, what we're going to do, we need to divide on both sides by this amount, which means it's the same as taking the reciprocal and multiplying. So notice the 1.145 power of 3 minus 1 is now on the bottom because we're multiplying, and what was in the denominator is now in the top. Do that calculation. M is by itself now. You can throw that all in the calculator. You could have calculated that one and then just divided all that by what you had in that one as well. So up to you which way you calculate it. And our answer gets to be 108,587.44, which makes sense. Like, you've got to pay off, you're gonna make 3 payments of that, come a bit more than 300,000. That looks reasonable over 3 years at that interest rate. So if we have a look at the 2, this time Maria's got a loan of $15,000. She's paying it in monthly installments over 5 years, and the interest on the loan is 16% per annum. So after 1 month, well, what does it look like? Well, she's had the 15,000. It's had interest calculated on it for a month. Now realise that because it's monthly installments and it's 16% per annum, we've got to divide the 16 by 12 because we want a percent per month. So it's our percent per month. And then we're going to make a repayment. So she's had interest calculated on the 15,000. She makes a repayment. It's going to look something like that. That's what your decimal is going to be for the 1 plus the 16 on 12, and it's minus M. So that's what she owes. The next part we want to do is, well, what is the amount of each monthly installment? So we want to work out the value of M. So we need to keep going with our pattern. The amount that was there in the first after 1 month, multiply by the interest rate, and then we make repayment. Gives us this statement. So it becomes squared, that part becomes squared, and the M's just times the 1.1013 recurring. Then the amount for the third month, again, we've got what we had for the second, after the second month, apply the interest, make repayment. And that's how it's going to keep going. Because she's doing it for 5 years every month, she goes for 60 months. So that's why we go to A60, and we have the pattern just forming, 15,000, the interest rate, 1 plus the interest rate, power of 60, and then a repayment, power of 59. And so on, down to that makes one more that last repayment, and A60 is going to be equal to 0, because she's paid off the loan. So what we do is we start rearranging it. So we start getting our equation we had here for A60 equal to 0, take all our values, all our expressions with M across to the right hand side, so they become positive. I've skipped a line because I've factorised them out and just taken the 1 plus the 1.013 recurring to the power of 1, plus 1.03 recurring to the power of 2, through to the 1.013 recurring to the power of 59. So we've got a geometric progression with 59 terms, 60 terms with the power of 59, but we've got 1 here. So R's going to be the 1.013 recurring, N 60. So there was R. A would be 1. So, and M's been factorised out the front. Again, we can calculate that, divide that side by that one, or take it and multiply it by the reciprocal. You'll see you get the same result, that M would be equal to $364.77. So set up your pattern as we've done all the way through. Realise how we're going to get M, and we can put it into place there.